Welcome! In the previous tutorial we built a smart switch, however it only worked for a single light. As I promised, in this tutorial I will show you how to create a switch that works for two lights. I will not go over the software and required hardware again, as I have already explained them in detail previously, so if you don't understand something, please refer to the first tutorial in the series. You can find the link in the description. Instead, in this video I will focus entirely on discussing the necessary changes to make our device work with both switches. Let me remind you that this video is a part of a longer series, in which we started with a basic switch control via Wi-Fi, but by the end you will be able to control your switch from the other side of the globe and monitor whether your light is on or off thanks to a light sensor. Summarizing, in each tutorial we are adding new improvements to our project, so make sure you don't miss next tutorials by liking this video and subscribing to my channel. Let's get started. Visit my GitHub repository by typing the URL you see on the screen or by using the link in the video description. Here you will find not only everything you need to know to do this project yourself, but also a lot of tips and recommendations. This time we will go to the folder containing the switch version 2.0, however I will also open the previous version 1.0 to show you exactly what has changed. The sketches shows us exactly how all the components should be connected to make our device work. When we compare the new sketch on the left with the one from our last tutorial that you can see on the right side of the screen, we can see that the only real change is the addition of a second servo motor. Its orange cable is connected next to the first servo to pin D2, where it will receive a signal from the microcontroller, instructing the servo motor on how to move its double arm horn to turn the light on or off. We will generate this signal through our web application. So one servo motor controls one switch and the other controls the second switch. It's a very simple change. We power our second servo by connecting red and brown cable accordingly. As before, we can check if the signal is being transmitted simply by looking at whether the LED is blinking each time we generate signal from our web page. So additional hardware part that we need is a second small micro servo like this. Let's connect it to our device. Hardware part is ready. Now let's move on to the software. First, let's take a look at what has changed compared to the code from the previous tutorial. We defined second microcontroller pin. The first servo is assigned to pin D1 and the second one to pin D2. We also changed the name of the variables. Next, we create two servo motor objects. We need also on and off options for the first switch and the same for the second one. That's why we add two additional buttons in our web page and style it so that they can be easily distinguished. My tip here is to create the attest.html file, copy and paste only the fragment with our web page. Next, style it, and then transfer back the ready version into our program. What I did, I set up my switch so that when looking at it, the first switch is on the right and it's moved by servo 1, while the second switch is on the left and it's moved by servo 2. Once our web page is ready, we can move on and modify the control servo function. This function retrieves the action parameter either on 1 or 2, off 1 or off 2 from our request. So for example, if the user sends a request like the one you can see on the screen, the signal will have the value on 1. And if signal has value on 1, the following actions are performed. The blink LED function is called, making the LED blink to indicate the signal. The servo is set to starting position 90 degrees. The program waits before executing the next operation. The servo moves to 120 degrees, so turns the light on. Another pause allows the servo to adjust to the new position, and at the end the servo returns to the starting position. However, if the signal has value of 1, the LED indicates the signal. The servo is set to a starting position in case it wouldn't be in that position for some reasons. Then program waits, the servo moves in the opposite direction from before, so it turns the light off. Another pause, the servo is reset to 90 degrees, completing the full cycle. And it works exactly the same for the second servo. However, this time we need to change the directions since it is mounted differently. At the end, both servo motors are attached to their pins, and that's pretty much all. Now let's copy the ready code from the GitHub repository and create a new sketch. I use Arduino IDE web application. It's free. You just need to create an account and you're good to go. Remember also to make sure you have Arduino Cloud Agent installed. It's a required plugin that enables serial communication between your board and the Arduino Cloud accessed via your web browser. Now let me log in. Now plug the microcontroller into your computer via micro USB, create a new sketch and choose version 1 since version 3 is not listed, and we can rename our project, but it is optional. Let's upload the program to our microcontroller. It may take a while, so I will double the speed of the video. You will see a blue light blinking in your microcontroller, which means that the program is being uploaded. Our program has been uploaded successfully. It's time to test our device. I'm using a piece of wooden board cut to the size of the servo motor, attaching double-sided tape underneath, and mounting the servo on the top of with a drop of super glue. Now, power on the switch, find your ESP Wi-Fi, enter the password you set, and visit the webpage to test it. Remember that you have different power options as well as versions without LED or breadboard. Thank you for watching my second YouTube tutorial overall and in this series. I hope it will be useful for you, and thank you for exploring this fascinating world of technology with me. Feel free to share your experience in the comments below or tag me if you build this device yourself. I would love to see the result and leave a like or comment. See you in the next tutorial where we will develop this project by adding a light sensor that allows us to monitor the light in real life.